The James Webb Space Telescope has just uncovered something that disturbs even seasoned astronomers, a vast, terrifying bubble stretching through the void. Imagine a celestial sphere so vast, so sharply delineated, that it is nearly as if it were made, not formed. It is not a planet, not a star, not a galaxy, but an iridescent void through the interstellar medium, a hollow wound in space itself, that defies everything we thought we knew about the geometry of the universe. It began as a glint in the data, almost nothing at all. In Webb's infrared survey, there was a dimming, a region of sky in which the background radiance of distant galaxies seemed to fade, as if engulfed by an unseen veil. It could have been an error, a calibration glitch, or a clump of cosmic dust scattering light. But when the telescope's instruments focused on the anomaly, the truth revealed itself, and it was far stranger. A spherical shell of ionized gas, hundreds of light years across, materialized. Its edges glowed softly, not in the hot blues and golds of star birth, but in an unearthly phosphorescence, light from shock-heated plasma. The astronomical community responded with a combination of amazement and incredulity. For decades, our theories of the interstellar medium had instructed us that big things build slowly, molded over millions of years by the gentle pressure of stellar winds and gradual material dispersal. This bubble, so clearly defined, so enormous, cannot and should not be under those laws. It is a challenge to gradualism, a testament to forces that act in brief, violent outbursts. Its presence suggests cosmic events that happen not in the broad light of supernova explosions, but in the quiet, hidden corners of the universe. It's as though the memory of something catastrophic, something so powerful that it remapped space, but didn't leave an obvious mark of its origin. Initially, the shape of the bubble seemed simplicity itself, an empty space scooped out of the cloud between stars, edged by a glowing ring of gas and dust. But spectroscopy tells a stranger tale. The gas is blisteringly hot, ionized by a torrent of high-energy particles and radiation. In every other such case we've ever seen, such heat is generated by a mighty central engine, a star cluster, a pulsar, a black hole feeding frenzy. But not in this case. Here, the center is vacant. No collapsed star, no rotating neutron star, no hidden black hole beam. Only quiet. Its symmetry is disturbing. Violent events in space rarely result in perfect geometry. Supernova remnants are twisted and chaotic. Even the massive superbubbles carved out of space by generations of stellar collapse are asymmetrical. This sphere, however, is nearly a perfect shell, as if the universe itself were pausing to admire its own work. The size is simply mind-boggling, nearly 1,000 light-years rim to rim. Just to give you an idea, if you place it where our solar system is, its rims would extend far beyond the spiral arms of the Milky Way's local community. Its shell shines with the spectral signatures of oxygen and neon atoms that had their electrons stripped away in fierce heat, and with the signature of dust grains that were torn apart in shock waves traveling faster than sound can travel through a whole star system. Within, the void is all but absolute. Gas is in such low density that infrared radiation is all but absent. Take a step outside the shell, though, and you're in a thriving frontier of molecular clouds, thick cradles of fresh stars ready to burst to life. The interface is razor-thin, a cosmic precipice where emptiness and plenty meet. In theory, such interfaces should fade over time as turbulence and particle motion diffuse the areas. Here, though, the distinction is sharp, as if a wound that won't heal. And then there's the motion. Spectral analysis indicates that the shell is expanding outward at over 1,000 kilometers per second, enough to cross the Earth-Moon distance in under 7 minutes. That velocity is not compatible with most stellar activity known in such an environment. A run-of-the-mill supernova, even in thin gas, would slow down quickly. This didn't. Whatever energy was at play must have been orders of magnitude greater than normal stellar death. Even more unusual is the age. From its size and rate of expansion, the object that formed it could have formed only a few thousand years ago, a cosmic heartbeat. And yet, no ancient or modern human civilization has left a record of a sky-conquering, blazing supernova in that area. Gamma-ray burst histories reveal nothing. It is as if the bubble just materialized. Examined up close, the shell is not smooth. Fine filaments and gas knots like sculpted pillars are suspended in high-resolution images. They are the fingerprints of the magnetic fields, twisted lines of force bending and stretching matter into shapes that cannot be formed by the simple motion of fluids. They cannot be accounted for by pure mechanical shock waves. They suggest an interaction with the galaxy's magnetic skeleton, the unseen lattice that permeates the stars. This is where the theories get bold. Some scientists propose that the bubble's birth involved magnetic reconnection on a cosmic scale, a release of stored magnetic energy comparable to countless supernovae detonating at once. Others invoke the collapse of a primordial black hole, a relic of the early universe, too small to survive until now unless it met its fate in a burst that tore the surrounding medium apart. Dark matter, unseen mass 5 times more massive than regular matter, comes into play too. If clumps of dark matter crashed into each other or ran through thick clouds of gas, could they produce such a shock? Dark matter in most theories interacts only through gravity, but if it can sometimes have violent interactions with regular matter, then the result could be a structure such as this, silent, gigantic, and enigmatic. And then, of course, there's dark energy, the mysterious pressure driving the accelerating expansion of the cosmos. Normally, it's a smooth, homogeneous pressure. But imagine if it isn't. A lumpy spike might inject energy into space, inflating a bubble of near vacuum that pushes matter out of the way into thin, glowing shell. That would rewrite not just our understanding of galaxies, but of the universe itself. The thermal structure of the bubble is another surprise. Warmth at a few million degrees Kelvin, the shell is hotter than usual young supernova remnants, but it is not X-ray bright as we might expect such heat to create. Rather, it radiates mainly in infrared and radio waves. This indicates particle acceleration processes more similar to those that create cosmic rays rather than those that heat supernova gas. If this bubble is a cosmic ray accelerator on a giant scale, it could be creating some of the high-energy particles that bombard the Earth, particles that could have affected our atmosphere, our climate, and even life itself. The bubble is more than a relic, it's a force that still shapes what's around it. Just beyond its edge, densely packed clouds of gas are folding into themselves, giving birth to new waves of stars. The pressure of the shell may have initiated this wave of birth, a phenomenon with which astronomers are familiar as triggered star formation. On this scale, entire star clusters may be formed as the bubble grows. It's destroyer and maker, in a sense, destroying what previously filled its core and planting what will radiate in its wake. Galactically, bubbles such as this would be agents of transformation. By tunneling through conduits for escaping hot gas, they could serve to control how galaxies recycle material into new stars. They might even determine the structure of galactic magnetic fields and the motion of matter on a scale of thousands of light years. This finding compels a new understanding of how galaxies breathe, grow, and develop. And to consider, without James Webb, we would never have caught sight of it. The shell of the bubble is faint invisible light, nearly invisible against the surrounding stars. But in infrared light, heated dust grains illuminated by the shock shine through. Webb's instruments, cooled to within a degree or two of absolute zero, can pick up this faint warmth with breathtaking accuracy. It is a reminder that the universe remains full of mysteries we have yet to dream of, hidden in the wavelengths our eyes cannot perceive. Now theorists are scrambling to explain it. Computer simulations connecting magnetohydrodynamics and exotic physics are in the works, but none yet match all the observations. Some models attempt to trace its properties back to the afterglow of a remote gamma-ray burst. Others investigate the idea of a collision between a neutron star and another object that somehow freed energy without the typical heavy element signature. The lack of those heavy elements is a major clue. Whatever it wasn't the familiar nuclear fireball we know. Ultimately, we might be witnessing something new, a new form of cosmic phenomenon never observed before, a phenomenon that will force us to re-examine astrophysics. For now, the bubble has no name, no face, and no mystery, a pristine sphere suspended in the void, defying us to discover its source. Perhaps, in the empty center of its hollow heart, there are clues to be discovered, vibrations of radiation, murmurs of gravitational waves from an explosion so immense that it scattered nothing else. Or perhaps it is utterly silent, a wound in the universe where all trace of the source of the wound has long since vanished. The James Webb Space Telescope has given us our first look at this mystery. It won't be the last. As it keeps looking, there is every likelihood it will find more, other bubbles, other voids, other traces left by things beyond our imagination. And each of them will be a reminder: the universe we think we know is stranger, more violent, and more beautiful than we can imagine.